Hi everybody, Rashid. So I will continue for this first week explaining the limit. And this topic comes after 2.1 in which we discussed the idea of the velocity and tangent problems. So those are kind of the foundation and they build up to the limit. And here we're going to see different definitions and we'll see the one-sided and limit as well. So I'll go ahead and maybe switch the screen to explain and get back to it whenever we need to. So this is section 2.2 and it's the limit of a function, all right? So let's review a little bit that previously I talked about the tangent of a curve. So please, if you didn't see this, you want to watch the previous video. And let's consider this function f of x, which is x squared minus x plus 2. And if you graph, you can use the algebra skills to find the vertex for this function and graph it there, right? Then you're going also to investigate. We'll see that later on. So that's one thing maybe to do. So you can see if x is near 2, which means from both sides, from the left side and right side, what happens to the value of f of x? What does it approach? So that's one question. And here, let's do that by the table, to investigate first by the table. This kind of problem is straightforward, but we want to understand when it's not straightforward what we need to do, because there is a deception that may happen. One will think that, okay, if the limit of this function, I'll just plug in the value. So you'll see here the cases, and I will explain these details. So if x approaches 2 this way, you see that the values of f of x go near 4, right? And if they decrease from 3 to 2, and you use these values, they also go near 4. So we can safely say that as x approaches 2, f of x approaches the value of 4. All right, which we can write as the limit of f of x as x approaches 2 is equal to 4. So that's kind of the idea, and this is going to be important. And as I mentioned, if you do the graph and you look at the graph, so x is the horizontal axis, you pick the values, then you see, you trace over the function as we go this way, what happens? Where it's going towards 4. And from this way, if it happens, which means it's coming down, you see they all go towards the value 4. So this is the basic introduction to it. And as I mentioned, the limit now of the function f of x as x approaches 2 is equal to 4. All right. So by kind of intuitive definition, we can say it this way, and so to read it correctly as well. There are different ways to read it, but this is one common one, is the limit of f of x as x approaches a equals to L, all right? And, but let me explain now where we won't fall into that deception through these 3 graphs. So let's look at A. You see here f of A is L, because this is a solid, it's there, the dot is there. You see here, there is a hole on in this graph, and there is the output for A. So here actually f of A is whatever this value is, let's call it M, right? But not this L, so f of A here is not L, right? And look at this graph, also there is a hole there, which means f of A is not L, right? So these are different graphs, and we need to understand what happens. So let's look. If we approach A from left, we're going towards L. If you approach it from the right, same thing happens. You see here, if you do this, same thing happens, just like A. And here, just like A and B. And in this one, but just like the previous example where f of 2 is 4, here f of, let's say 2 is not 4, f of A is not L, it's M. And the limit, it's still, right? Because what we are interested in is as X approaches A, what is the value, or we will see something that's not a value after, but now to this stage, what does it approach, right? It approaches L in all these three cases. And we'll reinforce this idea. So if you need to pause the video and go through it, you do that. So let's look at an example again, where it's not defined. So if you did this in college algebra or pre-calculus, you'll find that if we call this f of x, this function, and here the request is toward 1. But if you simplify it, since it's a difference of squares, and you get 1 over x plus 1, the degree on top is less than the bottom. So this is the horizontal asymptote. X equal -1 is going to be the vertical asymptote. So rational functions are important as well in calculus. And if you start plotting points, let's say x is 0, right? You get, I need to do this one here. It looks like it's a little bit high. Let's just say this is the asymptote there. This is there. All right. 1 over 1 is 1. X equal 1 is going to be 1 over 1 plus 1, right? So 1/2. However, you see, let's just do it for now and show. However, you see 1 cannot be used because the initial domain does not take 1. 1 minus 1 is 0. We cannot divide by 0, right? So we will put a hole there, right? And if you continue coming up with points, you'll come up with something like this. And you can graph the whole thing, but right now this is what we are interested in, right? So as 1, here it's 1/2. However, it's still undefined there because of the domain restriction, right? So I just gave the introduction as a review, but let's investigate. So we're interested in finding the limit of this function as x approaches 1. So approaches 1 means not 1. So we are interested in the values near 1, but not exactly 1. So if you investigate from the left, x less than 1, 0.999, 0.99, 0.5, and you substitute these values into the function, the x minus 1 over x squared minus 1, you get these values, and you can see as it's going towards 1, this is going towards 0.5. If you try it from the right side, the upper numbers, and as you pick in these numbers and you're going towards 1, it is going close to 0.5 again. So we can say that without looking at the graph, we can say safely that the limit of the function as x approaches 1 is 0.5. And you see here from both sides, it works both sides. And I did the graph, and that matches with it. And here we'll see the graph in a better view. So this is exactly what I did. And you see as x goes towards 1, this will go toward the half, and it's still going to get towards the half from here as well. So let's play with this example and say now we'll define g of x, a new function, with these two parts. The first one that we saw, however, if x is not 1, so now it's defined at that 1, and f of x or g of x equals to 2 if x equal 1, all right? So you've seen this type of functions. Okay, so let's put the graph. So the first one is the one that we did previously, f of x previously, but now it's still the same function. The second part of it is this part, right? All right, so let's go back. G of x equals 2 if x is not is equal to 1, right? X equal to 1, we'll put the dot at 2. That's it. The other part I graphed previously. So we have both parts in g of x. So this is what we're going to call g of x. All right, so now what do you think the limit is? So based on what we did, what do you think? Is it still going to be half, or is it going to change? Well, if you go back to this slide and its notes, you're going to decide that the limit is still the same because it approaches half from both sides, right? So we can still say that the limit of g of x as x approaches 1 is half. And the next part we're going to see is one-sided limits. And one-sided limits happens for the functions where it's not the same from the left and the right, like what we just did. And here is an example for it. So h of t takes the value 0 if t is less than 0. Let's say this is t. So less than strictly this. However, if t is greater than or equals 0, h of t takes 1. So now as you see, if we're if we're pushing x to be approaching 0 from this side, the left, f of x is going to go towards the value 0. However, when you do from the right side, maybe I should just do it here because x just going from this right side is going towards 0. the answer is 1. And you see 0 and 1 are not the same, so they are not equal from this side and this side. If this notation here, negative and pluses, are confusing, think about as the values less than t, which is less than 0. The values of t less than 0. This is what that means. The values of t greater than 0, and t here is x. So when you have the values greater than 0 and approaching it. All right. So just to explain a little more, and that's the clarification I mentioned to understand what this notation means. All right, so we can call this different ways as x approaches a from the left, or we can call it the left hand limit. So if you hear that I say the left hand limit, that means it's going towards a minus or the values that are less than a. All right, so that's I think that's not a big deal there. And you have, of course, different, I put here, you can pause and see different graphs, one approaching from the left and one approaching from the right, just like we did in the example. But now here is an interesting fact to know. If and only if, and we write it as abbreviation this. So the limit of a function equals to a value L, let's say here L, as x approaches a, if and only if it approaches that value or quantity from both sides, from the left and the right. So when you do the left hand side, on the right hand side limits, and you get L and L, you can combine the two in this. All right, so this is important to know. And what happens if they're not the same? This gonna be does not exist. Okay, so if this is L and this is M, this limit here does not exist. All right, this is an important example, and to summarize and conclude with it in a few minutes, but it's going to help you with almost all limit questions in the homework. All right, so let's look at this graph. We have the limit of g of x as x approaches 2 from, you see 2 negative means from the left. So think about it as x going, because this is 2, right? As x goes there here, so go ahead and project it over the graph. So this is the graph, means we're going this way. So as it's going this way, it's going towards 3, right? Now x approaches from the right, this way. So go ahead, project, right? That means you're going this way. And it's gonna come, when it's close to 2, it's gonna come to this place here, which is a 1. So now let's look, what is the limit of g of x as x approaches 2? Since these two are not equal, we're gonna say it does not exist, because it's gonna equal to 3 only if it does it from both sides, or it's gonna equal to 1 only if it does it from both sides. All right, so this is an important thing to know, when to pick does not exist. So let's look at 5 negative, and now I'll clean this and start it over. 5 negative. 5 negative, we're going to 5, which is this value here. So project, we're going toward 2. 5 plus there, the right hand side, it's going this way. It looks like it's going to 2 as well. All right, so they're equal. It's equal to 2. All right. And I put the solution for you here. So yes, that does not exist. And for the other one, g of x, and this is a good note to keep in mind, despite the fact that g of 5, you see, g of 5 is this number here. Let's say 1.5, not 2. Okay. The last part we're going to talk about here about limits is infinite limits, which deals with infinity. And for example, the example I gave of the, we can draw a new one. You know, if you just look at 1 over x, for example, you see, if you're in calculus, you need to know these basic functions and the parent functions. And you know, people that do interviews, we ask them these things, and for sure we don't want them to mess up, let's say 1 over x. That's something that starts from college algebra. X is when it's 0, it's undefined, so there is a vertical asymptote. And we're going to define here also the vertical asymptote. So when you try the numbers, you're going to get, let's say, something like this, right? So you see, now when we're dealing with 0, the limit of 1 over x, you see, if you go to, if x approaches 0 plus, you see it's going to go towards the vertical asymptote. It's going to shoot up. This is a positive side, so it's going towards a positive infinity. So what do you think will happen with 0 minus the left hand side? It's going to shoot down towards negative infinity. All right. So let's explain it here. That intuitive definition. The values of f of x can be made large, which means towards infinity, by taking x sufficiently close, which means for my example here as 0, close to 0. And the limit of f of x as x approaches a is infinity. That's the way you say it, or or you say the limit of f of x as x approaches a is infinity. Or another way for this one as well is f of x becomes infinite as x approaches a. So we can say that. And here, similar to the example I gave, here from both sides, f of x goes to positive infinity. If it goes this way or this way, you see it's shooting up both ways. It's shooting down, going this way or this way, it's shooting down both ways. That's why it's like this. And all right, so you can graph this function. We know 1 over x squared looks something like this. So with the negative at the front, it's going to have the reflection. It's going to look something like this. So it's shooting both ways towards the negative. All right. So similar definitions can be given to the one-sided, and remembering that we need to consider the values that are less, not exactly a, like in the example, not exactly the 0. And here are different ways, so you can pause again the video and see the different answers to these. So, you know, left, you see the graph is going up, all right? Same thing here, and this, right? So, as I mentioned in the first example, we have a vertical asymptote. And that's kind of, we can define it that way. The vertical asymptote, or x equal a, can be a vertical asymptote if the curve, if at least one of the following statements is true, right? This limit, this infinite limit occurs. And here is a trig question. There is some other details we'll talk about later on, right? But right now, to keep in mind, to understand these parts, to start working on the homework, then you're going to get maybe some other technical details. And you need to know the unit circle, right? So you know your trig functions. There are some videos to refresh online, how to build this in a short time. So find the vertical asymptote for tangent. People then, you know trig well, they know that pi over 2, for example, is going to be a vertical asymptote there. And here is the explanation, because tangent is sine of x over cosine of x. So when this is 0, we're going to have a vertical asymptote. This becomes 0 when x is pi over 2. Then when you look at this unit circle, you're going to find, of course, that the tangent, the left-hand side limit is infinity, and the right-hand side is negative infinity. And in the next one, you're going to have, you know, this is the tangent graph. So again, the left-hand side is right there, positive infinity, which is here. As it goes to pi over 2, it's shooting towards infinity. But as it comes from here, it shoots towards negative infinity. So the sine function, the cosine, the tangent, they are kind of basic graphs that everybody needs to know. All right, this concludes this video and lecture. Of course, as I mentioned, you will have a little more details when you work also with the TAs, and keep in mind these notes. All right, thank you. We'll see you in next one or in class. Thank you.